Okay, students, let's do a problem from section 4.1. We're asked to find the critical numbers of the function f of x equals x squared times e to the negative 3x. Now remember what critical numbers are. Those are numbers where the derivative does not exist or the derivative is zero. Now in this case, the derivative is always going to exist because we're dealing with a product of a polynomial and an exponential function. So what we're going to do is this: we're going to find values of x such that f prime of x is equal to 0. So we need to find the derivative. We're going to use the product rule. So we have x squared times the derivative of e to the negative 3x plus e to the negative 3x times the derivative of x squared. Now, the derivative of e to the negative 3x, we have to use the chain rule. We have e to the negative 3x times the derivative of the inside, which is negative 3. And then we have e to the negative 3x times the derivative of x squared, which is 2x. So I can write this as negative 3x squared times e to the negative 3x plus 2x times e to the negative 3x. Now, we have the derivative. We're going to set the derivative equal to 0 and solve for x. And to do that, we're going to factor. The GCF is x e to the negative 3x, so I have x e to the negative 3x times the quantity negative 3x plus 2. So using the zero product rule, we have x is equal to 0, or e to the negative 3x is equal to 0, which it never is, so that doesn't result in any solution, or negative 3x plus 2 is equal to 0. So obviously x is equal to 0 is going to be one critical number, and then if you set negative 3x plus 2 equal to 0 and solve for x, you're going to get x is equal to a positive 2/3. So the critical numbers for this function are x is equal to 0 and x is equal to 2/3.